So our example is find the distance between A, which is the point 14, and B, which is the point 312. So I've given you two coordinates, and all I want you to do is to find the distance between them. Okay? So for the first example here, we're going to just draw a sketch. The sketch doesn't have to be really accurate. In fact, I'm not even going to draw axes and plot the points accurately. I'm just going to think about where A is, and then I'm going to think about where B is in relation to A. So a bit like you would do if you were thinking about your straight line graph work and thinking about the gradient. So it's the same sort of skill, basically. So I know if I look at the points A and B, right, A is 1, 4, but B is 3, 12. So B is a lot further up and a wee bit further to the right. So I'm actually going to write B in first of all, right, because I know it's the one that's furthest up and furthest to the right, and then I'm going to do A down here somewhere, and A is 1, 4. So there's my coordinates, not plotted accurately, but again, in relation to each other, it makes sense because of where they are. So all I want you to do then is to think about where's the distance between A and B. So if I imagine the line going from A to B, then all I need to think about is, can I find the length of that line? And finding the length of the line is easy if you think about Pythagoras, right? Because Pythagoras is to do with triangles. So if I draw the right angle triangle in, the same as you would do if you're finding the gradient, right? Then it's easy to find those two distances. Therefore, you can find the third distance. And that's really all there is to it, right? But we're going to look at how we can do it without drawing the diagram as well, because some people might want to think about a formula for it instead. So let's think about the length of the sides then. So I know that from across this way, well, this one is 1 across, this one is 3 across, so the distance across the way must be 2. All right, do the same thing then for the second coordinate. This one is 4 up, this one is 12 up, and the distance from 4 up to 12 would be 8. So again, exactly the same as you would do if you were working out the gradient, but this time we're interested in the length of the line. So now if you're thinking about Pythagoras theorem, we know it's a right angle triangle, and we want to find the missing side. We normally call it x, all right, but x is the length of AB. Quite often I will still use x if we're using a diagram because it's easier to use one letter than two letters, because otherwise we'd have to use AB to represent that line. So you can call it x or you can call it AB if you want, it doesn't really matter. Right? And then you're just thinking about Pythagoras again. So a squared plus b squared equals c squared. Remember, the c has to be the longest side. So that's the c, and then the a and b are the other two. So c is always the longest side. So the x goes in where the c is. So I know then that 2 squared plus 8 squared equals x squared. Right? Work out what 2 squared and 8 squared is. Should be able to do that bit in your head. 2 squared is 4, 8 squared is 64. So the left-hand side adds to 68. And then the opposite of squaring is square root. So the square root of 68 gives us our answer. So let's just check what that is. So square root of 68 equals, let's just change it to decimal, 8.25 if you round it off. So 8.25. Now, if it's asking you for the distance, I'm not going to write centimetres this time, because if it's coordinates, it might not be on centimetre grid. So we don't know what the units are, so you just write 8.25 units, and that's your answer. Okay? So the reason I've shown you that way first is, that way means you don't have any big formulas to learn. All you have to do is understand that if you can draw the sketch of the diagram, you can actually see the horizontal and vertical distances, the same as you did when we're doing a straight line graph work for gradient, so you can actually work out what those are. Okay. The formula then, for anybody that is interested, and if you feel free to write this down, or if you think it's going to look confusing when I write it up, then maybe don't use it, because the diagram is just as simple. I'll be honest, 9 times out of 10 it comes to a question for an exam, I'll just go back and do a quick sketch of the diagram because I find it quicker. But the formula comes from looking at the coordinates. So when you look at this distance here, this is the distance between this point and this point. So we would call this the first x coordinate, and this would be the second x coordinate. So I know that the length of AB, right, we square, add, and square root. So what do we add, or what do we square first of all? It's the difference between 1 and 3. So it's the difference between the second x coordinate, take away the first coordinate. So we work out that. That's where the 2 comes from. Right? The 3 take away the 1 gives me the 2. So that bit would be 2, the change in the x coordinates. So we have to square that. And then we do the same for the y coordinates. So it's the difference between the second y coordinate and the first y coordinate. And we square that. So again, that gives me the 12 take away the 4. And sure, that's where the 8 came from, wasn't it? And then we know that the shortcut for Pythagoras is you square, add, and square root. So I need the square root of all of that. So there's a formula for the length of AB. But it looks complicated, doesn't it? It looks like the kind of thing that's not that easy to remember. And the only reason I remembered is because I understand the diagram. Right? If you asked me for that formula at the start of September, after the summer, I'd be pushed to remember that unless I actually sat down and thought about it. But maybe some of you are the type of people that can just learn formulas and apply them. But for me, it makes much more sense just to think, what's my diagram? And then that helps me remember the formula. So there's another method we could use. So if we were using that formula then, you would literally just put in there, x2 is 3 minus 1 squared, y2 was 12, y1 is 4, so 12 minus 4 squared, and it's the square root of it. So then we know that that's the square root of 2 squared plus 8 squared. So it is exactly the same as we did up above, but we're just using the formula. So root 68, or 8.25 units.